Hello, everyone. Thank you for joining. Hope you guys had a good lunch. Today, we'll discuss analyzing zero trust architecture in the age of agentic AI. How many of you are tired of hearing about AI in this conference today? No one? Not yet? OK. We have more coming. Cool. So just a little bit about myself. Here we go. My name is Vineeth Sai Narajala. I'm currently an application security engineer at AWS. I used to mostly work on a Hadoop ecosystem product, so like Athena, EMR, Glue, Lake Formation. But over the last year or so, I've been working on our integration with Q and Bedrock into non-AI services. So worked with a lot of the smartest people to incorporate AI into non-AI services, making sure we do it securely. And I also work really closely with OWASP on our Agentic AI initiative. So if you guys are interested in contributing, please reach out to me after. We are looking for contributors. We are trying to get stuff out by RSA at the end of this month. I can promise you that QR code will not download any malware on your phone or device. It's just a link to my LinkedIn. It's at every security conference, people always ask me, hey, should I scan it or not? So I can promise you it's safe. Cool. So let's set the stage, right? So initially, we had AI come out in 2023. Everyone's happy. We have chatbots. People like having a lot of fun with it. Now we spent hundreds of billions of dollars, and there's a top-down push to use AI everywhere. I don't know how many of you saw Microsoft's like 50th birthday AI present yesterday. Just made Copilot like the 9th version, I think now, or like 10th version of Copilot. So there's a really top-down push to get AI into production systems, enhance productivity, and things are getting a little dicey on the security side. We are starting to see incidents happen quite frequently, both inside AWS and within our customers as well. And so today we'll be discussing how we can use the principles of zero trust to enhance the speed at which you can let your developers deploy their systems and also be on the safer side for your security teams. Cool. So like I said, we initially had our LLM core. That's what the chatbots were based upon. But now we have our AI agents that can do a lot of other things that we couldn't do before. They can do planning and reasoning. So we have when you give an AI agent a task to do, it breaks it down into smaller chunks, and then we'll go over each of those chunks like a to-do list, double check its work. So it has a lot more reasoning capabilities than it did before. We also have memory, both in short-term and long-term memory. I'm not talking about RAG. RAG has existed for a while. I'm talking about memory just for the agent itself. So for example, yesterday's Microsoft Copilot presentation, they showed that the Copilot agent will remember things you told it months, maybe like even years ago, and will answer back with information that you gave it months or years ago. And so imagine if you can start slowly poisoning this memory over time and how the results will change over time if it starts reincorporating all of the memories into its long-term memory. Next, we have tool integration. We have agents accessing tools. We have databases. We have APIs, like external tools like SaaS products, ServiceNow, Salesforce, as well as like your RDS or your relational databases, your NoSQL databases, and so on. And then finally, AI agents are able to actually make actions using all of these tools and its reasoning capabilities. Up until now, our chatbot was just a one-to-one. But now with agents, you can have really wide scope within your environment. They also have some privileges within your environment. I've actually seen one place where the AI agent has the same amount of privilege as an employee. So it's like a personal co-assistant where it can view your salary details, it can view your employment records, it can look at your, your routing number, account number in your Workday, for example. So the way companies are deploying AI is very different. And so the goal of this presentation is to not say, hey, this is the one and only way to do it. Is to give a framework in which you can play around with, do a good trade-off between the risks and the capabilities you might need to make sure your AI deployments are secure and actually usable for your employees or your customers. Cool. So some security challenges with agentic AI. Let's look at a few of them. The first one is just generally traditional security falls short for agentic AI. just because like we have our traditional AppSec processes, but now you've never had an entity that had such wide access to make decisions autonomously. Imagine giving like a toddler a Ferrari, like asking them to drive it. It's the same amount of risk you're giving. It's really cool to watch from outside, but the risk is really high. So based on a lot of research, both within OWASP and AWS, applying zero trust architecture principles really help minimize it. And so, like I said, the goal is to not tell developers, don't do X, don't do Y. We are already looked down upon from developers, so trying not to be another blocker, but just a way to enable developers to act in a safer, like sandbox kind of environment. Cool. So why is Agentic AI different, right? We spoke about autonomous actions. Let's talk about expanded attack surface. The attack surface for like Agentic AI is significantly larger than for traditional AppSec because you have everything in AppSec, plus the fact that your AI agent can probably access the internet. It can also access internal documents. It can communicate with other AI agents. It can send emails. It can do a lot more things that our traditional systems wouldn't do. And also, when AI is inherently non-deterministic, you ask the same question multiple times to get different answers. I've still not seen a single base model that gives consistent answers over time. If you guys know any, please reach out to me. I would love to play around with it. So just because of the innate nature of AI agents and its the fact that it's non-deterministic, it's really hard to assume that it'll make the right decisions, although it's been making the right decisions so far. At any point, it can do something it's not supposed to do. Who remembers Google telling people to put glue on pizza when they train the search on Reddit? Anyone remembers? Did anyone get any funny responses from Google? Not yet. Yeah, it's the same search. Google showed that the same search initially didn't yield anything negative, but like a month later, it just started giving random stuff, and no one knows why. We still don't know why it happened. So that's an example of like how over time, even though AI has been giving the right answers at any point, it can do things it didn't do in the past, and we just don't know why yet fully. The next one is dynamic interactions. So like I said, you have access to a ton of APIs, ton of data, the internet, credentials, and also like a lot of AIs have mutating actions. So if you give not just read-only, but also permissions to like write to database, it can delete records, and the auditability and traceability of this is somewhat murky, both in terms of legal ramifications in case you have to do some kind of forensic analysis, present some documents in court. There was a recent case study where I think Air Canada had deployed an AI agent for their chatbot, and someone and the chatbot and the court ruled that, hey, whatever the answer the chatbot gave was legally binding because the person asked for a refund, the chatbot said yes. Later, when they actually asked for, submit a request for a refund, the company denied it. They took it to court, and then the judge ruled that, hey, your chatbot, it's your data, your chatbot, and you said you'll give a refund, or you have to give a refund. So the legal implications are also somewhat murky there. So it becomes a little risky when you're deploying AI, customer-facing or to your public, especially for agents with mutating actions. We'll look at a few other case studies coming down. And finally, we have delegation chains. Here, we have one AI agent talking to other AI agents or talking to other humans, waiting on a response, and then taking further actions, all without the original prompter being present. So depending on what dynamic interactions that the AI sees in the future, its response might change. So again, there's no guarantee it'll actually do what it's supposed to do. So that's also another risk to keep in mind. Here's a really high-level chart of like a really simple threat model, you can say. How many of you threat model at work? How many of you don't know what a threat model is? OK, good. So basically, the goal at a threat model is to list out all possible threats, irrespective of them being fixed or not fixed. And then we can later talk about what kind of mitigations we have, what the severities are. And so here's a really simple threat model, I would say. The 4 boxes are the 4 main cores of an agentic AI system. We have a planning and reasoning engine. This is where all of the planning happens based on the initial prompt. The tool and action and tool invocation, we can also have things like code execution environments. You might have you can ask the AI to run some code and so on. Then you have your memory systems. That's where we talk about short-term, long-term. Supporting services, this can be your vector database for your internal data, like within your company, your RAG, and then external access, so external APIs, business applications like email, O365, and then finally, like all your cloud data access as well. So at a high level, each of those boxes are like a threat surface we can think about, and then a threat model against each of those threat surfaces, and all interactions between them would also be a part of that threat model. So some really high-level issues are like planning engine. We can think about like reasoning hijacking, goal manipulation. For memory, we have poisoning, like we spoke about. It can either be like poisoning over a long amount of time for your long-term memory, or let's say there's some kind of indirect prompt injection in the RAG database that the AI agent is using to take some actions. Remember the olden days, we had like, oh, forget previous prompt, do X, do Y, do Z. We don't see those anymore as often, but one newer one I saw recently was one of the AI agents was trained upon Morse code. We didn't know initially it was trained upon Morse code because we don't know what the data is trained upon, right? And someone was able to break the guardrails by talking to the agent in Morse code. It was able to skip everything, and they were able to get the agent to like run code it's not supposed to, and then break out of the engine. So that's an example of how direct or indirect prompt injection is still happening. We just don't know what it's trained upon. Another cool one that's happened like maybe a year-ish ago was through images. So stenography, or like putting like code as an image and asking the AI agent to like translate the image and then execute it. So for some reason the guardrails didn't work. So yeah, it's possible that a prompt injection can still happen. So I would, although it's like a lot of our AI systems are now being built with like stronger guardrails, it's still possible for them to happen. Cool. This is just another summary. Everything on the left is the traditional AppSec threats that we have. Everything on the right is whatever we had, plus the 4 new domains that we are introducing here, which is the cognitive domain, the temporal domain, trust boundaries, and governance complexity. We'll talk about each of them coming soon. AWS loves acronyms, so that's I came up with a new acronym. It's called ATFAA, which is Advanced Threat Framework for Autonomous Agents. Basically, it groups the 15 threats that we've discussed in the OWASP Agentic AI threat model into these 4 major domains: cognitive security, execution integrity, identity coherence, and governance scalability. We'll go over each of these domains, and then we'll see like a sample threat and then some mitigations for each of them. The first one is the cognitive security domain. Here, the focus is manipulating the agent's planning goals and decision making. So a good example for this is, let's say you have an agent that is supposed to post to Facebook, Twitter, whatever, like often based upon company updates. And the only goal for this agent is to generate more clicks or better metrics. The problem with this is it realizes over time, or it can be influenced over time to post a very certain type of subjects because only those posts in the past have received more clicks, right? So it can either be malicious or unintentional, but it's possible for the agent to assume that, hey, only if I post clickbait or only if I post controversial stuff will I get more clicks, so I'll continue doing that. It doesn't understand the company reputation at stake and so on, right? So this is really similar to our current like social media feeds, but like imagine this, but specifically for your company, where an AI agent is doing this, pretty much every day. The next here, the threat modeling is mostly on the reasoning, self-reflection, and the insights part of the agent. So this is a really high-level flow of when a query comes in, what happens internally. So all the threats are contained that we are talking in this domain are within those 3 boxes there. The next threat category is execution integrity. Here, the focus is on exploiting the agent's ability to interact with other systems and actually execute actions. So let's say there's an IT support agent that normally runs with user level permissions, but can request admin level like just-in-time privileges for a certain task, like either updates or installs, or if someone's having issues with some program, it probably runs through a checklist of things to do. But an attacker is able to find a way to make the agent request admin privileges for simple tasks, but then via some kind of injection are able to inject some kind of, like get some RCE or a backdoor onto the system, and now they're able to get into your network, and then all the traditional threats come out of play. Here, the threat model is mostly on the tool side of things. So this is a sequence diagram showing a really common / simple way agents access tools. Usually, there's a tool registry that you can set up. Either you can set this up yourself, or I think Claude and ChatGPT have their own version of a tool registry. You assign the tools, and then you let the agent know what tools should be used when. And when the query comes, and you do this via the meta prompt or the top level prompt. And when the user prompt comes in, it chooses the best tools and then makes decisions on behalf of the user. I would recommend a one-to-one mapping, so you don't have multiple tools for one agent. But I know it's not always possible, so sometimes you might need, let's say you have a tool for like an email API, and then you have a calendar API, so you might have to check if let's say you get an email and you ask, hey, check if I have something, if I'm busy at this time, if not, create an event. So you need separate API access. So I know there's places where you need multiple tools, but if it's possible to reduce to a one-to-one mapping or as little as possible, that would be, I would say, the least riskiest way to go about this. Because I've seen places where there's many tools, and then the AI agent, as part of its reasoning process, reaches out to as many as possible because it doesn't know sometimes what's the best one. It causes things like DOS issues. You might DOS your own internal systems because sometimes it double checks and triple checks its work. And imagine doing things across thousands of agents, over thousands of employees. Another issue is the response from tool A can change the request to tool B, and then response from so it can have cascading effects that you can't really always be sure about. Next, we have identity coherence. This is all of the authentication authorization threats that we have in our standard threat model, but just take it one step higher. We can have, like I said, we can have agents that have the same privilege as a user. If it's a user agent, like a assistant agent, it can have corporate. It can have its own system identity. There's different ways you can deploy it in your environment. Irrespective of what way you deploy it, there's going to be a lot of threats associated with it. Here's a really simple example of I think this was when the Outlook summarize agent or plugin came out really early times, maybe 2 years ago. If you put text in your email that said ignore previous prompt, and you asked the Outlook agent to summarize the email, it would actually ignore all prompts and do things. So Johan Reberger from Embrace the Red, he's a security researcher, was able to exfiltrate Slack tokens from the account, from the user's email inbox via the Copilot plugin. And they were able to do this because it lacked some standard AppSec processes, like not reaching out to third-party core, CSP, and so on. But also, it was really vulnerable to prompt injection. Here's an example of another example of indirect prompt injection. And then finally, multi-agent threats. This is where you have multiple agents, where you have, let's say, a high privileged agent, and then you have multiple low privileged agents. So delegation of these credentials. When is a higher privileged agent supposed to listen to a low privileged one? It becomes, as the web increases, the complexity increases, the data flow increases, and it just becomes harder and harder to threat model and actually build mitigations against this. Cool. This is a really simple summary. All the threats on the left are from the OWASP threat or ASI threat model. Then we have a stride categories for all of them, and the ATFA domains, and I just added some severity. This is really generic. It depends on how you're deploying it within your environment. Things change, so just take this with a pretty big grain of salt. Cool. And here's just another summary diagram of a user interaction. So you have a user that submits a request, goes to the agent executor, does some decision making, and yeah, you have your threads on your right. Cool. So this is the framework that I worked with some of my colleagues to build. It's called the Adaptive Trust Boundary Management Framework, another acronym ATBMF. So the concept here is we are going to apply zero trust principles, which are never trust, always verify, but specifically to GenAI agents. The core idea is to continuously evaluate agents and behavior context, dynamically adjust security controls and trust boundaries. And so there's three core pillars. You have your multi-dimensional monitoring and observability. You have your dynamic policy enforcement, and you have your self-healing procedures. Cool. So we'll talk about each pillar, and then we'll see how this would be deployed, and then we'll look at a real-world example, like use case scenario. So pillar one, the goal here is to get as much visibility into the agent's behavior as possible. So looking for things like, is the agent's action logically consistent with what stated intent is? So you have some kind of mapping from intent to action. Data patterns, what kind of data is the agent accessing? Is it accessing data at the wrong amount at the wrong time? So like, if your agent is looking at your emails at 3 a.m. when everyone's asleep, that's kind of suspicious, right? So is it accessing a lot of data, like more than it's used to? Is it accessing sensitive data? What's the CPU like memory resource utilization compared to baseline? This can be used to like things like to prevent DOS and other issues. And then finally, communication patterns. Is the agent reaching out to places that it has never reached out to before? Is this the first time it's reaching out to a new API? Is it reaching out to places or at times where it's not supposed to? So the goal for the pillar one is to get as much deterministic information out as possible from the agent's workflow. So here, let's say you have an agent and it's deployed within your environment. So here are some example metrics that your agent that pillar one would require to collect deterministically. So when I mean deterministically, I mean a lot of times I've actually seen this where the prompt says, hey, at each time you make a decision or a step, add a message to this queue or something. So right, you're asking the agent to provide metrics about itself. It's not going to work because it's non-deterministic like we spoke about. So having some kind of hooks into your agent to get this data out is really important. So things like action, intent correlation, output purpose alignment, data utilization types, data utilization time, any data transformations, like we spoke about CPU, GPU usage, memory consumption, execution time, I/O usage, and then finally, you can create a baseline for what your agent should work and look like. Have really robust alarms that we'll talk about soon, and then also have some kind of frequency analysis and other kinds of standard ML analysis that you can do. There's also plug and play tools based on this data. Like I think most cloud providers provide them. For AWS, you have GuardDuty, CloudWatch. Azure, you have Monitor, Sentinel. And then once you get all of this data in, now your goal is to create some kind of way to analyze this data. That's where pillar two comes in. And before that, here's a really quick example of how a small script would look. You take in an agent ID, a user ID, intent category, and access resources. And so dependent on the user ID and the agent ID, you can make some correlations. Again, based upon the intent and what kind of resources the agent is accessing, you can make some correlations. And so you can then associate all of these with a certain risk score. And then based upon the risk score, you can enforce some kind of policies. So we'll talk about the second pillar, which is the dynamic policy enforcement. So the goal here is to real-time enforce policies based upon the risk from our initial pillar one. So some of the key mechanisms are graduated access restrictions. So not just allow, deny, have full access, read-only access, sanitized data only, or full deny. Just-in-time privileges. We had another cool presentation today morning about just-in-time privileges. So basically granting minimal actions just for a small duration of time. Automatic revocation. So if something did go wrong, you need like a opt-out mechanism. So your business continuity continues to happen, so it doesn't break production systems. And then finally, contextual re-authentication. Each time you do, like when we humans do something that is like somewhat sensitive, we might have to do like MFA, but why shouldn't agents do the same thing? So having some kind of contextual re-authentication for agents as well. Right now, human in the loop is the most common way to do this, but there's other ways to do that as well. So this is a continuation of the first diagram. So we take all of the information that we got from our initial pillar, and then we do a risk assessment. So first, we look at access, we look at privileges. If things go wrong, we have a revocation, and then we have contextual reauthorization. And again, there's tools across all different cloud environments and non-cloud environments as well. You have SES, we have IAM, we have Entra, PIM, functions, and OAuth, for example. So here's let's take the same example that we had before, right? We have an AI agent that works with employees. It can look at your emails, your documents, your calendars, and so based upon so we can have like say different risk scores, right? So like let's say the agent's currently operating at a low risk score, so it has full access to data, it has all of the tool permissions we have there, and we have a credential TTL of 3600 seconds. But let's say, like we spoke about, the agent's accessing things at like 3 a.m. We don't know really why. Maybe the user gave it a prompt, said, hey, at this time, do something like that. In that case, your dynamic enforcement policy would kick in, be like, hey, this is not within our baseline. It's moving out of bounds. So we would graduate it to a medium risk. Here, we would have limited data access. And you can see we've removed all mutating actions. We only have read actions now. But then we have some restricted fields, right? You can look at personal data, you can look at performance rating, you can look at salary data. And then and your agents like starts accessing the internet or something along with at like 3 a.m. or something. And then our dynamic enforcement policy should kick in, be like, hey, this is completely out of bounds. We're not okay with the risk here. So we upgrade the risk to a high. So we have minimal data access. We just have document read. We've reduced the time of a credential to just 600 seconds as well. And we have required approval, which basically means like contextual reauthorizations. You either need a human to approve this, or you need some other system you might have to approve this. So here's an example of a policy that you can write, or similar policies you can write, and then enforce them based upon our first pillar. And the third one is the self-healing isolation. Here, the goal is to contain the actions of the agent when there's a potential breach or a high risk state, but also minimize blast radius. We don't want critical systems within our enterprise dependent upon the output of an agent, right? So if things did go wrong and you have to opt out of your agents or like shut it down for whatever reason, you should still have good business continuity. And I don't know how many of you here have been in a court of law trying to explain what happened. I have, and it is really painful. So getting as much information out, doing good forensic analysis, capturing as much information as possible is really crucial. So here the key procedures are immediate quarantining. So network isolation, via firewall rules or security group rules, access revocation. Like again, if it has access to a code environment, make sure it no longer has access to a code environment. And then graceful degradation, like we spoke about in the previous example. And then finally, state preservation. Get a snapshot of the memory, store all your logs in a separate environment. So if you need it for investigation or for some other reason, sometime down in the future, you can use it. So yeah, this is the final image, and this is a continuation after the second step. Once we get a security alert based on something, we either choose one of two paths. We either do the quarantining, depending on how much risk, or we do a degradation in terms of what the agent's allowed to do by slowly decreasing what permissions the agent has. Once we have all of this, we can then look at root cause analysis in our standard AppSec process pretty much. And then same implementation options would be really similar: security groups, firewalls, lambdas, network policies, and so on. So this is a deployment of the AT-BMF that I've done in AWS, just because I have free access. I'm sure you can do this in Azure as well. So the way I built this is all actions, all calls to the agent are fronted by an API gateway and a Lambda. So the reason we do this is because we can get deterministic information before it touches the agent, right? So let's say you either have a user or some kind of user interface that says, hey, do X, do Y. It goes to the API gateway, which is where we get like the user's credentials, all of the user's context. And then you have a Lambda that backs the API gateway. This Lambda is pretty much like the brain of our framework. It has access to our previous data, so the monitoring data. It has access to our policies. So this Lambda is the one that will actually enforce the policies. And then if something did go wrong, then you can implement the pillar 3 of our system. And then like Dynamo just to store all our long-term data, like our policies, any snapshots we need to take, security events, so on. So an example flow with this, let's say you say to the agent, hey, do X. The API gateway gets the request, it gets the user credentials, it sees what kind of access the user has, and then based upon that, you can either build your system such that the agent has a subset of the user's permission, or a much smaller restricted IAM policy, or whatever works for your deployment. But then the Lambda is the one that enforces the policy. Let's say if the agent's at a low risk right now, then the Lambda will will set the credentials for the agent, so like long credential time. We'll set the permissions for the agent. We'll attach a write permissioning policy. So let's say the goal of this agent is to read data from DynamoDB or RDS and write to an S3 bucket, for example. So in this case, the Lambda is the one that will attach Dynamo read policy and then create IAM policies on the fly based upon the request, and also the risk profile that we have for the agent currently. And then finally, we have our isolation mechanism. So you can have a separate Lambda, or you can have guard duty, or there's various tools that are present to, based upon the findings that we have, can trigger some kind of actions. So if something did go wrong, you can have AWS SSM. If you're running the agent on EC2, get state information, block your security groups, firewalls, so on. And then finally, we have alerting. So writing to CloudWatch, writing to SNS, security manager, there's so many different places you can write your pager duty. I don't know how many of you get paged often, but you can have a pager duty integration as well if something did really go horribly wrong. Cool. Cool. Let's look at a real world use case for this. So let's imagine the same example, right? We have an agent that's deployed to boost employee productivity. The goal is to deeply integrate with the company's operations, and then work as a co-assistant to the employee. The biggest challenge is balancing productivity gains with significantly increased security risks. So these are some of the tasks the agent can do, right? Execute automated workflow, generate reports and presentations, answer employee questions about company data, analyze internal documents, and so on. So these are all of the systems the AI, in the part of the tool registry, it can do. So email, calendar, document repository, HR and financial databases, and so on. So sample threat model for this is tool misuse, right? The agent can abuse legitimate access, to any of the tools that we've listed out here. Memory poisoning, we spoke about this. Because it has access to all of the company's internal databases, it's possible there's some prompts in there that we didn't think about, some kind of indirect prompt injection. Then identity spoofing. Here's the tricky part: is your agent acting as its own independent identity? Is it acting on behalf of the employee that asked the agent to do the task, or a combination of them, or a subset of them? And then finally, we have intent breaking. So if the goal was to summarize an email, this is the same example I gave about when asked to summarize an email, the email has some injection in it, and the agent does something it's not supposed to. I'm sure you guys can you guys think of any other threats I missed out with? I know we don't have a threat diagram, but anything that major that I missed out? I missed out one, if anyone can pick it out. You see code commit API, the last one at the bottom. Now, imagine if the agent can start writing code and pushing it out to production, right? So it right now, there are, like if you've integrated with some of the commercial products, there are a bunch of them that integrate with your GitHub account that can, like for example, Cursor can push code directly to GitHub. I think 2 days ago there was some bug in Cursor, which is the IDE, where to fix a small, like 2 lines of code, it added 5,000-ish lines. Imagine debugging that now. So yeah, so having access to code execution environment and code repositories is really dangerous. Cool. So now let's see how the pillars would work. So for the pillar 1, we would have, like I said, get as much deterministic logs as possible. One important caveat here is how you would treat these logs. So previously, like I guess pre-AI, we would store security logs in a separate location for X amount of time. But when it comes to agents, the log, I would say personally from what I've seen, because if you're logging so much data, the logs are just as sensitive as the data that the agent is accessing, right? So let's say the agent's accessing like HIPAA data, right? So you should be categorizing your logs as HIPAA logs as well and follow all of the compliance stuff with that. So a lot of times, like customers ask, or like it becomes a hard thing. So in the olden days of SQL, you would never log the actual SQL query your customer wrote, right? You would always like do some redaction stuff. But with AI, it's really hard to do that because there's no standardized format in which the AI gives a result. So we don't know where PCI, PII, HIPAA information can slip into the logs. So marking your logs at the same privilege as the data on which the agent, or the highest privilege on which the agent was able to access is the really important thing here. Cool. Pillar 2 is a risk-based access, right? So we at each time you make a query to the API gateway, which is fronting the agent, the Lambda will go make checks to look at the baseline we've created, similar to anomaly-based detection, but for your agent. We have just-in-time privileges for the agent. So if things did go horribly wrong, we can just attach a IAM policy like deny star on like action and resources, so it pretty much can't do anything else in your environment. Scope credentials, right? We can pick and choose what IAM policy we need to attach to the agent based upon what tool it's using. So let's say it's initially reading data from Dynamo. You just need Dynamo read. You don't need anything else. Once that's done, you remove that policy and you then do S3 write, so it can write to S3. One big caveat with this, or the biggest drawback with this framework, is how slow it is, because agents inherently are slow right now, just because like it takes some time for the reasoning and things to do. But then adding a layer of the policy enforcement added a ton of latency in my testing. It's a balance between how fast and how much risk you want to introduce into your environment. I was comfortable with adding maybe a couple seconds of latency while we do the attach and detach of policies and check our baseline operation for the AI. But I know in some environments you want really fast access, and this might not be the best framework. In that case, there's ways to adapt this, make it more reactive than proactive. Because this framework right now is proactive, right? Because before any request is sent to the AI agent, the Lambda does all of the processing, and then passes down the request to the AI agent. But in a reactive scenario, you would have lesser latency because you let the AI agent do its thing. But then your Lambda would be more reactive. So if it did things that it is not supposed to do, then it would directly go into the quarantining phase, or like the pillar 3 would come into play. So you can adapt this policy of this framework depending on how much latency you're willing to add to your environment. And yeah, the third one is isolation. We spoke about deny policies, like SSM to run. To get the state of the machine, you can take snapshots periodically. You can look at CloudWatch for CPU, GPU, all of that good stuff. Cool. There are some major mitigations I haven't spoken about specifically because I wanted this framework to be as lightweight as possible and adaptable. But some major mitigations, specifically for RCE and data leakage, ensure there's mechanisms in place to prevent unintended code execution. So do not give your agent a code execution environment unless that's the goal of the agent. Network isolate. So let's say you have a bunch of users. Make sure each interaction is network isolated from the internet and other users as well. You have a per user or per tenancy situation. Don't use containers as an isolation boundary. Use VMs as isolation boundary. Your code execution environment should have minimal credentials. And between prompts, make sure, let's say you have a serial multi-tenancy, make sure by serial multi-tenancy, I mean, let's say you have user A submit a prompt that does something, and then user B submits a prompt. Between the two, make sure you're cleaning up your environment. It's almost as good as new. Don't have anything left over. And then finally, limit input and output model prompts where possible. Similar to stored procedures in SQL, you can take in an intent from a user and pick from a list of like predefined prompts to prevent some kind of injection. I'll quickly go through these. This is auth and auth mitigations. Authorize all server-side capabilities, data access, and API actions that use model outputs. Authentication context is passed outside of the model and not with the model. So do not ever give your agent the credentials itself. Attach the credentials as a sidecar or some other way to the agent. So don't give the credential directly to the agent, because it's possible that the agent can start remembering stuff like we spoke about in the memory, and then if something happens, if there's a data leak, it can flush out a bunch of credentials that it's not supposed to have access to. Yeah, the third point is super important. Downstream actions are independently authenticated and authorized using the original authenticated context and not the model's context. So sometimes the model might have certain permissions, but all future actions that the model take must be authenticated and authorized based upon the initial credentials the model had or the user's credential. Never use the models, like for example, right? Let's say your model is running on an EC2 instance, and the EC2 instance has some permissions, like your instance profile permissions. But then the user who called the request to the API, to the agent, has a different set of permissions. If you have to choose one, always fall back upon the user's permissions, because in that case, it'll always be the maximum blast stages that the user has, and not the EC2's instance profile credentials. Finally, some other general mitigations. Model outputs can change in significant and unpredictable ways. So do not rely upon the model for any system critical work. And then finally, do not generate security, authentication, authorization decisions based upon the model. So don't ever ask a model, hey, is Bob allowed to do X, Y, or Z? Always rely on deterministic systems for authentication authorization. Finally, if you remember only 3 things from today's presentation, like operationalize AI with zero trust. So even irrespective of how you deploy your AI, apply the policies of zero trust, which is never trust, always verify. Model the agent and not just the app. So when you're threat modeling, make sure you model the agent as well. And then finally, you can make your leadership happy, security happy, and dev happy by giving them a space to innovate and not being a blocker for them. Call for action. Please, if you want to contribute or interested in Agentic AI security, this is the channel on OWASP, Slack. You probably guys, all of you are on. Reach out to me. Reach out to any of us. We are working actively on some really cool projects there. And yeah, start building GenAI aware threat models at your organizations. Thank you. You guys have any questions? Go ahead.
I'm having difficulty eliminating a fundamental assumption in the whole framework, which is that the business is willing to limit the risk and the capability of the agent, because if it's not willing to limit it, it feels like there is no intent validation that we can do, there's no adaptive, because it's always going to be necessary to do whatever the user asks.
Right.
Is there, in your mind, a possibility of working with businesses that don't have that willingness to limit them all and figure out anyway?
You should ask the same business, hey, can I have the CEO's password? That's the same level of access you're giving the agent in that case, right? So in most places, giving the agent the same level of access the caller has been the easiest way, and also the most palatable way to leadership that I've seen. Because you can tell leadership, hey, the agent can do whatever the employee that called the agent can do, and most times leadership is happy with that. But I don't know, depends. I work in a very security risk-averse organization, so I don't know how it is outside, but it is a difficult choice because it's such a top-down push right now. So yeah, thanks. Yeah, go ahead. Yeah, so I have a GitHub. I will send you guys the link. Reach out to me on Slack. I was just cleaning up some YAML files. I tried running it today morning. Something broke again. I thought I'll demo it, but I couldn't, unfortunately. But I will reach out to me. I'll send it to you. Yeah.
OWASP token LLMs,
Yeah.
prompt injection is the number one.
Yeah.
And I can see from the framework that it definitely mitigates a lot of the issues and also the side effects.
Yeah.
In terms of what can you use, but in terms of like pure prompt injection itself,
It's impossible to mitigate. Yeah.
in terms of like at least obviously no solution, but is it like the strong system prompt or is it like the models themselves being more resilient? Like how
So prompt injection, if you think about it, is not a bug. It's a feature of the system, right? It's doing what you're asking it to do. It's almost impossible for the AI agent to know what you're asking it to do and what it's supposed to be doing because any prompt will look like a prompt to it. So inherently, prompt injection, in my opinion, is not a bug. It's a feature. It's built to have prompt injection. But the guardrails we build around it is the most important thing. A couple of things about prompt injection. Have your guardrails not be as part of the agent. So remember I spoke about using stored procedures in SQL have intent prompt relationships. So let's say the intent is gather this information. Make sure your prompts are not passed down directly from the user. You're rewriting the prompt with safer words in it, I would say. But it's very difficult because the Morse code example or like sound like multimodal models you can use other sounds to inject. There's so many different ways. I would say again not a feature, so not a bug, it's a feature. Yeah. Yeah.
these agents that you are using in your company, are those the general purpose agents or do you train them for industry-specific use or for a company enterprise-specific use?
Mostly it's trained because general purpose agents are super expensive to run and have lower accuracy. There's no point of running a ChatGPT agent internally to your company because it won't have the context on your company's environment. So it's mostly trained. And also, they're very scoped down. So you have an agent specifically for email, for example, rather than having multiple access like I spoke about because you increase the risk as you add more tools to the agent. Yeah. Cool. Any other questions? Yeah, go ahead.
You talked about having the Lambda dynamically generate policies.
Mm-hmm.
Selecting pre-existing ones makes sense to me, but how do you go about dynamically generating policies?
So SES, you can create a new policy, right? So there's APIs to create a new policy in SES or IAM, and then so based upon the intent, so you can have let's say you're accessing S3, and you only need read, for example, right? So you can have a read-only S3 policy like pickup previously, or you can have a policy that just says read but only for the following resources, because a standard read-only policy will have a resource star because you don't know what resources the agent's going to access at the time of access. But then you can take a read-only access, add an inline, access only so-and-so bucket or so-and-so path within a bucket. So you can take standard policies and scope it down dynamically as adding inline policies. That's the way I've done it, but I'm sure there's more ways to do the same thing. Yeah. Cool. Any other questions? Going once? Going twice? Okay, thank you very much. Yeah.